It is the tendency of particles to be transferred from higher concentration to lower concentration region. This phenomena is called as mass transfer. Examples for this mass transfer in our day-to-day life is humidification of air in cooling tower. Next is evaporation of petrol in carburetor on an IC engine. Then next is transfer of water vapor into dry air, and last one is dissolution of sugar added to a cup of coffee. This is some examples of mass transfer in our day-to-day life. Next, we are going to see the two modes of mass transfer. First is diffusion mass transfer. Second is convective mass transfer. This diffusion mass transfer is divided further into two types. It is called as molecular diffusion, and next is eddy diffusion. It is the transport of water on a microscopic level as a result of diffusion from a region of higher concentration to lower concentration region in a mixture of liquids or gases is known as molecular diffusion. Next is eddy diffusion. When one of the diffusion fluids in a turbulent motion, eddy diffusion takes place. Its mass transfer is more rapid by eddy diffusion than by molecular diffusion. Next is isothermal evaporation of air into water vapor. We have the picture here. This is a tank which is having water with the level of x1, and the height of the tank is x2, and the level above the water and the tank is called as x2 minus x1, and the next is MA is evaporation rate. We are going to solve this problem. We have 4 assumptions. It is the system is in isothermal and the pressure remains constant. Next is system is in steady state condition. There is a slight air movement over the top of the tank to remove the water vapor diffuses to that point. Next is both the air and water vapor behave as an ideal gas. These are some assumptions. Next is we have a formula for its molar flux. It is given by MA by A. It is like a heat flux. We have MA by A is equal to dA by GT. We have MA by A is equal to DAB by G into T into P by x2 minus x1 ln of PA2 by PA1. Now DAB is diffusion coefficient. It is in terms of meter square per second. Next is molar flux. It is given by kilogram mole per second meter square. G is a universal gas constant. It is 8314 in terms of joule per kg mole Kelvin. Temperature, it is given in Kelvin, then pressure is in bar. These are the terminologies we are going to use. PW1 and PW2 are the partial pressures of water vapor, and it is given in figure. Next is we are going to solve one problem to determine the diffusion rate of air from the bottom of the test tube of 25 mm diameter and 35 mm long into dry air at 25 degrees Celsius. Take the diffusion coefficient of water in air is 0.28 into 10 power minus 4 meter square per second. We have data from this its diameter. D is equal to 25 mm. In terms of meter, 0.0025 meter. Then length is given by x2 minus x1. It is shown in figure. It is equal to 35 mm. It is equal to 0.035 meter. Temperature is 25 degrees Celsius. We have to substitute in terms of Kelvin. So you have to add 273. So 298 Kelvin is obtained. Next is diffusion coefficient DAB is equal to 0.28 into 10 power minus 4 meter square per second. It is in our given data. To find the diffusion rate of water, we have to use the formula. It is MA by A. MA by A is called as molar flux by isothermal evaporation. G is universal gas constant. P is a total pressure in 1 atmosphere. It is equal to 1.013 bar. It is 1.013 into 10 power 5 Newton per meter square. Next we have to substitute the area. Area is equal to pi by 4 d square. Now d is equal to 0.025. So you can obtain area is equal to 4.9 into 10 power minus 4 meter square. Substituting the area, substituting the gas constant, substituting the DAB, you can get MA is equal to 5.09 into 10 power minus 10 kilogram mole per second. Next is you have to find the mass rate of water vapor. It is equal to its molar rate of water vapor into its molecular weight of water vapor. We have to find the water vapor's molecular weight. It is equal to 18.016. It is in our data book. Next, to find the mass of water vapor is equal to 9.170 into 10 power minus 9 kilogram per second. This is our final answer.